Hi everybody. In this video we're going to talk about absolute extrema, and extrema is a different word for minima and maxima, which are the plural of minimum and maximum. We'll also talk about how absolute extrema are different from relative, and that they can also be the same. Alright, we're going to consider three different graphs just to show you examples of them. So here's a cubic graph, and let's say that the x-axis is like this, so it has three real roots. And let's label, this is A, this is x1, this is x2, and this is d. Now x1 and x2 are critical values because the derivatives there are 0 and 0. So these are both, this is a relative max, and this is a relative min. But the question here is, where is the absolute maximum? And the absolute maximum would be the ultimate highest y value on the interval from a to d, and that maximum value would occur here at d. And the maximum value of f would be the y value here, but we would say x equals d is where the absolute max occurs. Similarly, the absolute minimum is here at a because a is the lowest of the y values. So here's an example where, yes, we do have a relative max and a relative min, but the absolute max, in this case the absolute min and the absolute max are at different locations, and the absolute max and min are not relative maxes or mins. Here's a different example. So let's say we have maybe the same graph but a different interval, like this. So you could imagine that the graph continues going on this way, but we are restricting the interval just to be from here to here. So again, we have four x values, a, x1, x2, and d. And again, here we have relative maxes and mins at x1 and x2, but you can clearly see that x1 is the absolute maximum. So in this case here, at x equals x1, we have both the absolute max and x1 is also a relative max. Similarly, down here, x2 is a relative min because it's minimum in this neighborhood, and it's also the absolute min because it is the lowest value of the function. Another example is having one of the relative points be absolute but not the other one. So here we have a, x1, x2, and d. And again, x1 is a relative max, x2 is a relative min, and also the absolute min because it is the lowest of the y values. And then over here at d, d is not a relative max, but it is the absolute max because it's the highest value. In order to determine where the absolute max or min is on an interval, so let's say on, we could do a to b, and almost always these will be closed intervals, we will use something called the candidates test, because there are candidates for what the, or where rather, the absolute max or min could be. So the candidates here, in this case, are x values. They are the x values where the relative or absolute, they're the x values where the absolute max or min could occur. Those x values, those candidates, are any critical points, so in this case x1 and x2, and also the endpoints a and d, or in this case a and b. So what we'll do is we'll say, okay, the candidates here are a, and then x1, x2, and maybe dot, 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 and then b, where here a and b are the endpoints of the interval, and then x1, x2, etc. are the critical points of f of x. What we're going to do for each of these values is plug them all into f of x. We don't have to plug them into f prime at all. We can just plug them into f, and then whichever one is the highest would be the absolute max. And whichever one is the lowest, wherever it is, would be the absolute min. And that's pretty much it. We don't actually have to do the first derivative test or anything like that to justify things. We can just find the highest and the lowest values. So let's see an example. Find the absolute, or ABS, max and min for f of x equals x cubed minus 9x squared plus 24x minus 6 on the interval 0 to 6. So my first step is to find candidates. Well, I already have the endpoints, 0 and 6. Now I need to find my critical points. So to do that, I'm going to take the derivative of f. So f prime of x was, 3x squared minus 18x plus 24. We're going to set this equal to 0 and factor out a 3. So 3x squared minus 6x plus 8. Factoring this again will give us 3x minus 4 and then x minus 2. Therefore, my critical points here would be x equals 4 and x equals 2. So our candidates test will look like we'll do it down here. We'll do a little chart. So over here, I'll have my x values, and then those are 0, 2, 4, and 6. And then I'll have my f of x function. And if you want, you can rewrite it here. You could rewrite x cubed minus 9x squared plus 24x minus 6. And notice that this is f, not f prime, because we're plugging them back into the original. So when I use 0, I have 0 cubed minus 9 times 0 squared plus 24 times 0 minus 6. And that's 0 minus 0 plus 0 minus 6, which is negative 6. And then for 2, I'll have 2 cubed minus 9 times 2 squared plus 24 times 2 minus 6. And I would like you to do these without a calculator, so there's some arithmetic here. 2 cubed is 8. 2 squared here is 4, and 4 times 9 is 36, so minus 36. 24 times 2 is 48, and then minus 6 here. And here's a nice way to combine these. So do the easier math first. 8 minus 6 is positive 2, and then 48 plus 2 is 50, and then 50 minus 36 is 14. So our second value here is 14. For 4, these numbers get a little bit bigger, so 4 cubed minus 9 times 4 squared plus 24 times 4 minus 6. 4 cubed is 4 times 4, which is 16 times 4 is 64. 4 squared is 16. 16 times 9. So to do that, we'll do some scratch work down here. So for 16 times 9, what I like to do is I like to do 16 times 10, and then subtract 1/16. Because if you think of 9 as 10 minus 1, then you can do 16 times 10 minus 16. So that's 160 minus 16, which is 144. For 24 times 4, I can do a similar trick where 24 is 25 minus 1 times 4. So if I distribute this, I get 100 minus 4, and 100 minus 4 is 96. And then minus 6, and again I'll use tricks to combine these. So here, 96 minus 6 is simply plus 90. And then when I have 64 minus 144, the 4 minus 4 will go to 0. 60 minus 140 is negative 80. So this will become negative 80 plus 90, which is a positive 10. And then the last one is some very large numbers. 6 cubed minus 9 times 6 squared plus 24 times 6 minus 6. 6 cubed is 216. 9 times 6 squared is 9 times 36, which is 10 minus 1, times 36, which is 360, minus 36, which is 324. Then we have 24 times 6, which is 25 minus 1, times 6. 6 times 25 is 150, and then 150 minus 6 is 144, so plus 144. And then minus 6. And again, we can be clever about combining these. So 216 minus 6 is 210. And then negative 324 plus 144, again, we have a positive 4 and a negative 4, so those will cancel. And then we have negative 320 plus 140, which is a negative 180. 210 minus 180 is 30. So we're going to clean this up to see our 4 values, although we can see them right here. But here are the 4 values that we get. These are the y values. We got negative 6, 14, 10, and 30. And clearly, this is the lowest value, so this is the absolute minimum. And 30 is the highest value, so this is the absolute maximum. And that's pretty much it for using the candidates test. We can confirm that what the graph would look like. So because the original equation is a positive cubic, it's positive x cubed, the graph should look like this. And then based on the relative values of the relative values of the candidates, we can actually tell how high or low these things are. So this one is 0, -6 because it is the lowest value. Then we have a relative maximum here at 2, 14, and that's the 14 value. Then it goes back down to a relative minimum at 4, 10. Notice that the 10 is less than the 14. And then the absolute maximum is at 6, 30.